Hello, I am Dr. Lara Sruji, and I'm a pediatric intensivist and cardiac intensivist here at WVU Medicine Children's. I'm also the director of simulation for the Children's Heart Center, PICU, and CICU, and the lead of the ECMO education team. Welcome to ECMO 101. In this module, you will learn the basics of ECMO, including how it works, the types of ECMO, indications, exclusions, cannulation, and how to activate ECMO here in our unit at WVU Medicine Children's. And welcome to our virtual ECMO environment. As you navigate this module by clicking on the subheadings, you may also explore the room by clicking on various items and videos to learn more. In this first segment of ECMO 101, you will learn what ECMO is and how the circuit works. ECMO is the most advanced type of life support. It's a therapy used to support patients with severe respiratory or cardiac failure despite maximum medical therapy. It is a temporary therapy that we use to buy time until the patient recovers. ECMO stands for extracorporeal membrane oxygenation. Extracorporeal means outside the body, like dialysis. It pumps blood out of the patient, oxygenates the blood outside the body using a membrane oxygenator, and returns it to the patient. We often also refer to ECMO as ECLS, or extracorporeal life support. What are the components and how does it work? Cannulas drain the blood from the patient and return it. There's a venous cannula and an arterial cannula. This is the pump. It pushes the blood forward. This is the oxygenator. It is a hollow fiber membrane. O2 and gas go in fibers like alveoli and the blood flows around it. This is where gas exchange and thus oxygenation happens by diffusion. There's also an O2 blender and flow meter. This is the oxygen and medical gas supply. We can adjust the FiO2 from 21 to 100%. This will be the main way we control the patient's O2 sats and PaO2 when they are on full ECMO support. Next to that is the sweep flow meter. We can control the sweep gas flow from 0 to 10 liters. This is what controls how much gas flows through the oxygenator. The higher the flow, the more gas exchange occurs, and specifically, the more CO2 is removed from the blood. There's a heat exchanger that warms or cools the patient to maintain normothermia. There's a monitoring system that measures flow and pressure in the system. The flow sensor in green tells us how much flow goes to the patient. In yellow, you can see several points in the system where we monitor pressure. Venous, before the oxygenator, or pre-ox, and after the oxygenator, or post-ox. Changes in these numbers signify where the problem might be when flow is decreased. The CentraMag screen shows us multiple areas referring to specific ECLS circuit values that are continuously monitored. These values have certain parameters set by the perfusionist that will create an audible alarm should the value exceed the parameters set. And here you can see what these components look like in actuality. Thank you for participating in ECMO 101.